Hi, my name is Abby Gervase, and I'm going to talk to you guys about psychology and reproducibility, why psychology studies are failing the reproducibility test. In August of 2015, Brian Nosek undertook a giant project in which 270 contributing authors attempted to reproduce about 100 psychological experiments. The concept behind this was pretty simple. They just picked studies that seemed to have had conclusive findings, decided what results in their opinion would qualify the study to pass the reproducibility test, and then performed the tests. All these experiments had previously been viewed as having very definitive results. However, Nosek and his colleagues found that only 39 of the tests actually passed the reproducibility test. So, why are these tests so difficult to replicate? This isn't exactly a new problem. In 2011, psychologist Diederik Stapel was investigated for and eventually confessed to committing scientific fraud. This fraud had taken place over many years and had affected as many as 55 publications. He wasn't the first, as two other psychologists, Karen Ruggiero and Mark Hauser, had previously been found guilty of similar fraud. The main thing that all three had in common is that they were all known for having very thought-provoking studies that had attracted a lot of interest. In addition to these scandals and Nosek's study, in general, psychological studies have been found to be very difficult to replicate. Let me give you an example. Pretend that you are the owner of a company and the manager of one of your stores, Mr. Miller, has a contract that is up soon. Mr. Miller has contributed to the store in some ways, but he's also detracted from it in others. Do you renew his contract or not? Now, say I give you these two pieces of evidence. Mr. Miller has attracted new customers with imaginative promotions, therefore his contract should be renewed, and Mr. Miller's actions have led to a lack of clarity in the store concept, therefore his contract should not be renewed. So, which piece of evidence do you feel would have impacted your initial decision more had you known it before you decided? Seems like a pretty straightforward psychological test, right? So what if I told you that in 1965, two psychologists named Friedman and Sears found that people tended to pick information that was consistent with their original choice. Like if you chose to renew Mr. Miller's contract originally, you would say that the fact about him finding new customers would have impacted your decision more. However, in 1981, a different psychologist named Frey found that people actually tended to choose the evidence that was inconsistent with their original decision. And then, in 2008, another group of psychologists concluded that if you were only given two pieces of evidence, then you would probably pick the one inconsistent with your original decision, but if you were given more options, say 4 consistent and 4 inconsistent, then you'd probably pick a consistent choice. But then, in 2015, Kate Ratliff with the reproducibility test found that the original results from 1965 were actually correct, and people would usually pick the evidence that's most consistent with their original decision. So what's going on here? Clearly there's an issue if the same experiment run basically the same way 4 times yields 3 different results. Well, for one, psychology is a relatively vague science that is very easily disrupted by things like researcher bias. This is particularly because many psychological tests focus on the idea of priming. This is essentially like activating the placebo effect just the right amount to make people do something interesting without having them realize what you want them to do. It's basically like finding the delicate balance of inciting a subconscious response to something without inciting a conscious response to something. One example of priming is something like when I give you a word completion task like this. Now, this one was pretty obvious, but a number of you probably thought dark because I primed you by changing the background of the slide from white to black. On the other hand, some of you probably picked one of the many other words that could have fit here. This might have happened because I didn't prime you enough by changing the slide color, or because I was way too obvious and you realized what was going on and actively chose not to go with your first word choice. As you can see, priming is a pretty slippery concept. There's also a pretty big issue with the overlap of researcher bias and priming, in which researchers, knowing which responses would get them the result that they need, might lead the test subject too much towards those responses, which means that the response the subject provides isn't a genuine subconscious response to the priming. But also, the whole point of priming is to lead a test subject to a certain response. So basically the whole thing is very confusing, which is why we're engineers and not psychologists. However, there's also a pretty big issue in the way statistics are applied to psychology. Most, if not all, scientific studies judge the statistical success of an experiment based off of the p-value the data yields. From a set of data, a p-value tells you the odds of the null hypothesis being true, which is basically like saying, what are the odds the results I got from my test happened completely by chance? The generally accepted p-value is 0.05 or less for published papers, because if your p-value is below this, your results are considered to be statistically significant. In reality, this is probably not the best way to judge the effectiveness of an experiment. When statistician Ronald Fisher introduced the p-value in the 1920s, it was just meant to mean, these results might not be completely random, you might want to look into this more. The main problem is that it doesn't take into account the probability that the result you get actually could happen. Also, many researchers have a really bad habit of engaging in p-hacking, which is the idea of exploiting researcher degrees of freedom, like retesting until you get the result you want, dropping conditions, or monitoring and editing data.
P-hacking is very complicated, but it basically means collecting lots of variables and then playing with your data until you find something that counts as statistically significant but is probably meaningless. For example, the website 538 surveyed 54 people and collected over 1,000 variables, and through p-hacking the results, was able to find statistically significant correlations between eating cabbage and having an innie belly button, drinking iced tea and believing Crash didn't deserve to win Best Picture, and eating raw tomatoes and Judaism.
This p-value issue is clearly demonstrated by the Reproducibility Project's graph, where you can see on the left all the p-values are below the 0.05 limit in the original tests, but on the right, more than half of the reproductions are far above that limit, and some are even almost at 1. There's also a number of issues within the scientific community in general. Unfortunately, the amount of interest that an experiment generates tends to be based more on how innovative or unusual the experiment is, and less on how definitive the results actually are. Also, replications are rarely viewed as publication-worthy and often face much harsher scrutiny than the original tests. For example, in 2010, a psychologist named Daryl Bem conducted a study that he felt proved the existence of precognition in a number of people. This study got a lot of press, but obviously it had a number of skeptics. However, when 3 separate research teams failed to reproduce similar results using the same exact method, they found endless roadblocks in the way of publishing the results. One team's paper had been rejected after peer review even learned that Daryl Bem had been one of their peer reviewers. Another pretty big issue is the idea that those who replicate tests are just viewed as not having the skill to balance the idea of priming the perfect amount. For example, when a popular experiment by psychologist John Bargh from Yale University failed to replicate for a research team at the Free University of Brussels, instead of viewing this as a failure of the original test, many said that the Brussels team just didn't have the skill to replicate the experiment. One prominent psychologist was even quoted saying that Bargh has a knack for it that not all of us have. And finally, there's also the problem that no one wants to change the way statistics have been used and taught for the past century, and everyone just views p-values as the be-all end-all. In reality, we should probably be focusing more on the idea of effect sizes, which measure how big an effect a study had, as opposed to just seeing whether or not it had one. So, who are the stakeholders involved? Well, first of all, obviously Brian Nosek and other members of the Reproducibility Project have impacted this issue by helping to bring it to light. Also, psychologists are stakeholders whether they're the ones producing unreproducible studies or the ones trying to expose unreproducibility. Also, the scientific community as a whole is affected by this issue. For example, one analysis found that only 6 of 53 high-profile papers in cancer biology could be reproduced. Finally, I believe that this issue affects everyone. Not only is it having an impact on the effectiveness of psychological studies, but also the issues within researcher bias and p-hacking have been found in other fields of research too. Like it or not, scientific research affects everybody. So what are the main ethical concerns relating to psychology and reproducibility? Well, for one, false information is constantly being fed to both the psychological community and the general public as a whole. Also, many psychologists don't see a problem or just refuse to accept that their work is invalid. For example, Dr. Bargh, the man who supposedly had a knack for priming, actually published writings about how bad of researchers the Brussels team must have been after they failed to reproduce his experiment. But also, the main problem is probably the fact that no one is actively trying to conduct inaccurate studies. In fact, in the papers collected in the Reproducibility Project, many of the authors talked about how helpful the researchers of the original experiments were in setting up the reproductions. Obviously, the original researchers hadn't been trying for false results when they ran the original tests, so they had probably felt that the reproductions would just prove what they had already found. But because so many reproductions have failed, we know that something has to change. So what comes next? Well, first of all, we obviously need more studies like the Reproducibility Project. For example, while the idea is still a long way from being developed, there are those in the psychological community that have suggested that grad students be required to perform reproducibility tests. Not only would this be good practice for the students, but also would validate or invalidate a lot of studies very quickly. Also, the fact of the matter is that data analysis, both within the psychological community and the scientific community as a whole, definitely needs to be addressed. It's going to be hard to find a way to improve a system that's been in place for almost 100 years, but it has to happen sometime or we'll just keep getting the same unreproducible studies. Finally, it'll be important to stop focusing on how interesting a study is and start looking at how definitive the results are and how effective the study can be. In the end, I think the thing that we as potential future researchers can take away from this is the fact that we always need to be questioning the world and community around us. I believe that the conclusion of the Reproducibility Project paper said it best. After this intensive effort to reproduce a sample of published psychological findings, how many of the effects have we established are true? 0. And how many of the effects have we established are false? 0. Is this a limitation of the project design? No. It is the reality of doing science, even if it is not appreciated in daily practice. Humans desire certainty, and science infrequently provides it. So, I hope you've learned a bit more about psychology and reproducibility, and I hope that if one day you should find yourself doing research in any field, you'll avoid making some of the mistakes we've seen, and all your results will be reproducible. Thank you for your time, and I have one last question. Apple or banana? Did you pick banana? Then consider yourself successfully primed.